Alright, hey, it's been a while, but welcome back to some Calculus with Keller. We're going to wrap up our talk about derivatives, at least our introductory talk about derivatives. We're obviously going to talk about them for a long time as we go through this chapter. So let's first of all, let's start with a little review. Let's do a problem together that we did in class, one similar that we did in class. And so we're going to use that limit approach right now to find the derivative of the function f of x equals x to the third plus x squared. And so just a little bit of a reminder here. Remember that the derivative is defined as the slope of the line that is tangent to the given function. And so what we're going to do, since the slope is constantly changing for this function, we're going to look at it from a limit, and we are going to find the limit as that change in x approaches 0. So as we get closer and closer and closer to a given point, as that secant becomes looking more and more like a tangent, we're going to find the limit of the slope formula that finds the slope of that tangent line. And remember, to do that, we're going to use this structure right here, and we're plugging in x plus delta x everywhere we see x in the original function. And that's going to be a little bit difficult in this problem because we're going to have that to the third power. So you might want to find your blue sheets right now and find a nice easy shortcut to how do you take a binomial to the third power as I finish up setting this problem up. And so again, so what is that x plus delta x to the third power? What is that when we expand it? And according to my blue sheets here, it says it's going to be x to the third plus 3x squared delta x plus 3x delta x squared plus x to the third. Or sorry, excuse me, delta x to the third. That's just my first part now. That's just that. I'm going to underline those just to kind of get you an idea of what goes with what. So now I have to expand the other part of it. I'm going to FOIL that out and get x squared plus 2x delta x plus delta x squared. And so that's that part. And so that's the full expansion of when I plug x plus delta x into the function. And now I'm going to run that negative sign through on the second part. So man, there's a lot of terms in this problem. But before you freak out, understand that a lot of that's going to cancel. And so I'm able to cancel those four terms out, which isn't really a whole lot. But as you might remember in class, as I look through the rest of these, every single one of these terms has a delta x term as a part of it. And so I'm going to be able to cancel out a delta x out of every single term here, which will enable me to go back to the substitution technique and evaluate what the limit is. And so now that I've simplified this a little bit, I'm going to evaluate the limit as delta x approaches 0. And so remember, that means that every time I see a delta x term still in this problem, I'm going to plug 0 in for that. That's going to really eliminate much of what we see here. So that second term becomes 0, that third term becomes 0, and that last term becomes 0. And what I really have left then is just 3x squared plus 2x. And remember, that has a lot of names now. That's the derivative of the function. It's the slope of the tangent. It's the slope formula of the tangent lines to that function. So remember, that slope is going to be different at each individual point. Okay. All right. So I hope that makes sense. Please make sure you do some of those practice problems today following the video. Last kind of example I want to show you before I turn you loose on your homework is this one here. And what you're going to do here is you're going to find the equation of the line tangent to a particular function at a particular point. So the only difference right now is we are going to find the equation of the line, not just the slope of the line. Remember, the derivative is the slope. We're going to actually find the entire equation of that line. So what's needed for that? What do you need to write the equation of the line? Obviously, if you need the slope and you need the y-intercept, but how do you find those two things? So obviously, number one, we need a point. All right, in this case, that point's going to be given to us. That point is -3, 4. Remember, that's going to provide the x and the y for us. And like I just mentioned, we need the slope. And how we find the slope? We find the slope by finding the derivative of the function. So we're going to go through that process again right now. Go through that limit process. So again, work on this, practice this, get better at this. Use this example as a pattern or as a frame for your own work. And now here we go. We're going to find the limit as delta x approaches 0. And I'm already plugging in x plus delta x into the function. And I'm subtracting just the function itself from that. All of that, of course, over x plus delta x minus x. Been through this a number of times. Let's expand that out. Have all of these terms that we get when we do all of that expansion. Be careful with this. Be careful with distributing. Be careful with running a negative sign through a parenthesis. Those are all little mistakes that can really mess you up. I'm going to do a lot of canceling here. Canceling my x squareds, canceling my 2x's, canceling my 1's. In addition, I'm going to cross out a delta x out of all of the remaining terms. And when I'm done with all that, that leaves me with my derivative, which is 2x plus 2. Not only is that the derivative, it leaves me that middle term as well, but when I evaluate that as a limit, that middle term is going to go to 0, and then that will leave me 2x plus 2. That is the derivative, remember, but it's also the slope formula for this function. Meaning what? I can plug in any value of x that I want right now, and that would give me the slope at that particular x value. So if I want to know the slope at -3, 4, I have to plug -3 into my slope formula. So when I do that, I get -4. That is the slope at that point. So now that I have slope, and now that I have that point, I can go ahead and write the equation of the line. How do we do that? Old school algebra right now. Plug in your 4 for your y, plug in your -4 for your slope, plug in the -3 for your x, solve it for b. B is -8, put it all together, y equals -4x minus 8. What does that really mean? What are we looking at right now? That is the equation of the line that is tangent to x squared plus 2x plus 1 at -3, 4. You could actually graph the function and graph this line right here, and you would see that they are tangent to each other at -3, 4. So I'd like you right now to try this on your own. Alright, I'm going to give you the function x to the third plus 2x. I want you to write the equation of the tangent line to that function when x equals 3. So after you see all the information on the screen, I'd like you to pause this video. Please do that. Take the time to go through this work. If you need to start the video back up and go back and look through it again, or just refer to your notes if you took good notes, do that. But pause the video now. I hope that you actually took the time to do that. When you did it, you should have found that your slope formula was 3x squared plus 2. We're going to plug x equals 3 in for that. When you do that, you're going to get a slope in this problem of 29. That means the slope is incredibly steep at that point. Now I'm going to plug in my x and my y. Now I know my x is 3. How do I figure out my y? Well, just plug 3 into the original function and figure out what the corresponding y value is. So 3 to the third plus 2 times 3 equals 33. So I've got my m, I've got my x, I've got my y. Put them all together into your slope-intercept formula. Do the algebra for that, work that out, solve for b. So b is going to equal a negative 54. So our equation is y equals 29x minus 54. Hey, if you would, pause this again right now. Graph these two functions. Graph x to the third plus 2x. Graph y equals 29x minus 54. Look and see. Move your window so you can see what happens at x equals 3. See how they're tangent to each other. It's important that you recognize what it is that you're really doing right now. Were they? Did it work out? Hopefully you should have seen the two graphs were tangent, touching at one point there. Okay? You need a little practice with this. You're going to have a homework quiz tomorrow, so please make sure you do these problems on page 270. It might look like a lot because I'm writing a lot of them out, but in reality it's probably only about 10 problems, if that. Spend the time the rest of this hour working on this. Come see me if you have questions. I'll be here later this afternoon or tomorrow morning. I'll be more than happy to work with you on this.